Okay, so I am not going to be with you guys for the first week, but since we have the internet at our fingertips, we're going to go ahead and use it. So what I have is computer-aided manufacturing up in Blackboard. I'm in course content, and it starts with what to do first. And so let's start at the beginning. Download Autodesk Inventor student version. Follow this link that I've provided for you. You should be able to load that in if you don't already have it loaded. Then you're going to load the model. It says, for example, Module 1, it's the 1, 2, 3 block model in the Module 1 file folder. We'll look at it in a second. You're going to open the model in Inventor. You're going to follow the attached video. You've already been able to do that because you're watching this video. Then you're going to submit the work. So I've got Module 1 on here, and it is beginning on the CNC mill. Load the file, follow the links, submit the work. Let me pop it open and we'll start to go from there. So Module 1 looks like this, and it's going to be a 1, 2, 3 block. It's got a 1, 2, 3 block file in there. That's in Inventor. And then after you create the file, apply the machining to it, save the file, then you're going to submit it into the Module 1 submission box, and that's right now worth 100 points. So that's what I'm going to have you do for week 1, to get all of those things loaded up and get ready to go. So you're just going to click on the link, and then you'll open it, save it, however you choose to do that. I've already got mine loaded up here, and this is the 1, 2, 3 block. This is just one of our normal projects, and so I've got Inventor loaded up. It's got all of the stuff from the model there. For the most part, we'll be able to just leave these alone. We're going to be working on this CAM tab for the bulk of our time. So I'm going to start walking you through what it takes to do this part. So I'm going to go in CAM. And so at this point, I have no machining applied to it, but I'm going to go in, I'm going to do that. I'm going to go in, and I'm going to do a setup right here. So I go into setup, and so immediately it's going to start kind of asking me some questions about where I want this part to be, how I want to start this part. And so this is where you got to kind of want to start to know some of the things about this part. This highlighted yellow area around there, that's the stock. Here's your UCS icon, that's for your X, Y, and Z. And so what I want you to do is I want you to go ahead and put that, well, I think we could actually just leave it right here for this part. We're going to add some stock around the part, and then we'll go ahead and just do our work to keep it pretty simple in this first one. So we are in milling, and we are going to leave our stock right here. And so if we go to look at the bottom of it, we see that our X0, Y0, Z0 is on the top of the stock, and it is in the middle of the part, so in the middle of that dowel hole. So I can click front, that'll give me my front view. And so if I go over here into the second box under setup, it gives me the size of the box that I want to have. I can go ahead and add in however much stock around it. So for the side offset, it might be, let's say it's 1/4 of an inch. That makes a 1/4 of an inch larger box around it in just X and Y. It doesn't change the Z at all to it though. So if I go here, I can see I don't have any bottom offset. If I want to do a top offset of, say, 50 thousandths, I can make it grow. If I want to do a bottom offset of 1 inch, I can put a big stock block around the bottom of it. So now it's a lot thicker on the bottom. It doesn't really change what I'm going to machine, but it's just larger on the bottom. So I go back to 0 there, brings it back. Okay, so that's my stock, that's my box. That can be changed as we go. This first one, we're just going to play around with it just so we can get it, just kind of get an idea. If we wanted to go ahead and put in dimensions, we can do that. So let's just say we're working with a box. This gives us a box that is 3.5 by 2.5 by 1 inch 50 thousandths tall. So we can handle that. We don't really need to do anything with this right now. We can name it, and it could just be 1,000. And if we want to put any kind of program note in there, we call it 1, 2, 3 block. first try, since there'll probably be some changes on this as we go. When you look at the work offset for it, 0 is G54, 1 would be G55, 2 would be G56, and then if you have a probing option, you can also use it, or you can use multiple work offsets. So we're going to leave this alone like this. Okay, so we've got our setup. First thing that we want to do is we're just going to come in, and so you may have some tools set up, you may not have some tools set up, and sometimes you can go off of what you already have. But what we're going to do here, since this is a brand new one, probably doesn't have anything set up, so we're going to go in and face it. We're going to go to Tools. And so we can go into All Tools, and we can see just a giant list of tools. So what I want to do is I want to try and find a 2-inch shell mill if I can, or some kind of a face mill, and I can just kind of start typing and see what it brings up. So this gives me a number 1 of a 2-inch diameter face mill, and I can select it. So it hasn't done any machining to it yet, it's just selected that face mill. And so I can come over here and see what it is that I want to cut. I'm going to click on it. And what do I want to cut? I want to cut this face right here. So it highlighted that area. And where do I want it to wrap it to? Any of my clearance planes, any of that information is located here. Then how I want to do the machining is located here. Do I want multiple depths? Single depth? Do I want to leave some stock? No stock? And then here we go for just the way we want to lead in, how we want to thin the chip, any of those information that we want to have in there. So right now we're just going to keep it super basic. So once you see this area highlighted right here, so setup 1, tool 1, face 1, it's number 1 tool, it's a 2-inch face mill. This is just the information for our work offset. This tells us that we created the actual machining event. We're going to make some changes in this so we know what these tools are named. So we'll just go in and we can come in here and click on it once, give it a second, click on it again, and then you'll be able to rename it. Face off. I want you to just follow along as I do these things too. So this is what you'll submit with me. Okay, so now if I want to simulate that, I can come in here and I can just hit play, and it's going to be able to simulate. If I want to see it here, simulate, push play, that's going to face off our part. You can change around a lot of those things. Right now we're just going to do this super simple. So still, X0, Y0 is the center of our block, Z0 is the top of the stock, tool 1 is a 2-inch face mill, and all we've done is come across it and we've taken care of our stock. I want you to set this up for, let's just call it for right now, we'll say it's a piece of aluminum as we set up our part. So we can change some of those things in our setup for the type of material that we're working with, the type of programming that we're using. If we're using any kind of fixture, we can also go in and change it at the tool where we can see feeds and speeds as to what kind of tool that we're using. So as you can see, 6,500 is our RPM, way too fast. We can work on that now or we can work on that later. So we can go ahead and go on down, stay in setup 1, and we can mill around the outside of this. And so we're going to go to 2D milling. You can either click here, or you can stay in this box and right click, new operation, 2D milling, and we are going to contour around the part. So we're going to pick up a new tool, and we go to all tools again, and let's just call this let's search for a 3/4 flat end mill. As you arrow over, you're going to be able to see some options as far as how fast you're going to go and how many flutes this thing has and what's going on with it. So this is for cutting aluminum. If I want to go to a low carbon steel, go over there, 3/4 end mill, low carbon steel. So I should be able to go all the way around the outside of this. I want to leave some stock though. About 10 thousandths as they go around it. I want to select this bottom box. Okay, so I can watch it now. I'm milling around the outside of my part. So again, I'm going to left click. I'm going to give it a second left click again. I'm going to call this roughing outside. Now if I want to, I can go ahead and just copy this. I can just paste it down below it. Go in and rename it. Finishing outside. I can do that a couple different ways, or I don't even really have to do it that way. So I'll come in here and I can change tools. Let's see, I pick a 1/2 inch flat end mill to go around the outside of it. And go down to low carbon steel, select it. And come back over here. I want no stock to leave. Okay, so if I want to go back and run this all the way through, go back to setup, I hit simulate. Base milling, 3/4 mill around the outside of it, 1/2 inch of mill around the outside of it. That brought that to size. Okay, so with inside of this, there's lots of other options that we can use. As of right now, I'm not using any kind of cutter compensation. I'm just letting the machine do it all for me. I can go in and change this so that it won't matter what size end mill that I use, where I can use cutter compensation, where the control inside can help me do those things. We'll get to that as we go. Right now, let's go ahead and start doing our hole work. When we're going to bring in a spot drill, we'll spot drill all 5 of these holes. We'll do all of our drilling, reaming, and counter boring for them. So we go to drill, pick a drill, all tools, and I'm looking for a 3/4 spot drill. Go ahead and go across, low carbon. So I got my spot drill sitting there. It can start wherever you want it to. It doesn't have to necessarily start right there. So hole faces, I always think, is kind of a strange question because I don't really see it as a hole face. But what it's asking for is the chamfer on it. And it's going to be able to detect that you have different depths going on there. I'll go ahead and rename that. 3/4 spot drill. looks good. It almost always looks great in simulation, but it doesn't always mean that it's going to come out perfect as you do it. So I can go ahead and start going through with my drilling. Click over here into the front if I want to do my front view. If I'm not sure what size my holes are, I can go back here to model, and then I can start to kind of work some of these holes and know what size they are. So this hole is 375. That's going to be a reamed hole. Hole 2. .3/8/16. So we've got two 3/8/16 holes, one 3/8 reamed hole, and then we've got the two counterbore holes to work with. So these two holes are 630 for the counterbore, and they are 390 through. So that gives us 3/8 reamed hole, 3/8/16 tapped holes, and then counterbore is 630 and 630 on the counterbore part of it, and 390 through it. Okay, so I just go back here to CAM, and still I've got my first part of it done. I can kind of choose to go however I want. I'll probably just go ahead and bring my counterbore holes in first. And so let's go back, and we'll do, anytime that you go back into the drawing, do any kind of changes or adjustments to it, you may see these all X'd out. Doesn't mean they're ruined. You just need to go back up and hit generate up here into this corner. And you want to just regenerate the machining to it. There you go, you're back to normal. So you're still in setup 1. And you're going to go into drilling, and you're going to change tools, and you're going to go to a 390, 3.7 probably is the closest tool for that. Let's go 3.9. All tools, let's look at drills. Search by diameter. 370. Those are spot drills. So we can look 23 and mils. Let's see, we can also search by if we know what the fractional size of that drill is, we can work off of the fractional size. So a 25/64 drill would do that. Find it that way. If we have to make a custom one, we can as well. So there's one. Slip over here, grab the low carbon option. So that is going to be 390 for these two counterbore holes that are down here. So come over here, got the drill. We're going to now select the holes for it. It says select hole faces. It's going to be the diameter and the diameter. There's a couple of really cool things. It'll actually, you can pick it to select all the diameter holes there. So if you click here, it says select same diameter. You can go in and actually just choose one hole, and every diameter hole that is on that part, it's going to seek it out and then select it. You can do some different options here where you can order inside out. You can optimize the order. That's how we'll do it. We can order by depth, so you can go down or up. You can do a lot of different things in here. For just 2 holes, it's not really going to make much difference on how we do it. So here again is my height. Now if I want to do this, is real simple drilling. This is just a G81. I can go in, I can do a deep hole drilling for a retract. I can choose my peck depth, 0.1. I can dwell if I want to. I don't want to. So it looks like my drilling came out okay. I'll go ahead and go through it. Okay. Now, what it did not do was go all the way through the holes. So I'm going to come back in here, see if I can do a little bit of adjustment here through this. I'm going to go ahead and take I'll let that one go down about 300 thousandths. Below it. So now I'm going down through the part, where before I was not going through the part. So you're always still making small adjustments as you're going through there. So that's 2 counterbore holes that are through. We'll go back again and we can just go in and do a new operation, drilling. And we're going to change tools, and we can go to a, let's just use a 5/8 end mill for that. Let's go to all tools. Slide end mill, find the low carbon option for it, get into a spot where I can see it, over here, select my holes, two holes, if I want to peck, I can. I'm only going down a couple hundred thousandths, and I've already got most of the meat of the hole taken out, so I'm not even going to worry about that. I'm going to compress some of these so we've got some more room so we can see. Now it is running my tools 1, 2, 3, 4, 5, 6. It doesn't always have to be like that. All right, so at this point I've got all of my holes spot drilled. I've got these 2 holes drilled and counterbored. Now I can go ahead and run my tapped hole for both of these. So new operation, drilling, drill. Change tools, and I've got a 3/8/16, so I need a 5/16 drill. That's going to be under all tools. Low carbon. Which 2? I want to do this one, and I want to do that one, and I'm going to have to go down below it. Maybe thousandths. Just want to make sure I'm getting through it. Alright, so simulate it. It's not pecking, so I need to go in and peck that one. Deep hole drilling, maybe 80 thousandths. Takes care of that drill. Lather and repeat on this one, so I'm just going back in and drilling again. Tap. Select it. Select my holes. Probably gonna have to go down below it again. Not go quite down as deep. 60,000, that'll be about one thread past it. Probably make some adjustments on that as we go. So there's our tab. Now all we have to do is do our reaming. New operation, drilling, drill. Tool. At this point, that's going to be a 3/8 reamed hole. So I want something that's pretty close in that. As far as fractions go, we'll just try to find something and letter or number drill that fits that. So a U drill would be a 3/68. That'd be a pretty good one to use for that. Whether we choose to do it out of steel or aluminum, that really won't make any difference. So I'll type U, go under all tools, see if I can find a U drill. No. Let me just see if I can find it this way. Under all tools, search for just drills. So I switched here to diameter, so that'll just kind of refine the search. So I went to a diameter as 3/68, and that just gives me 3/68 drills, low carbon, select. And that's already at my hole, so I'm set up pretty good there. Come in, select it, then go down below it because I want to go through it. A lot of this will just be some repetition. Okay, so I've drilled that hole. If I want to, I can just do a copy paste. I can duplicate, go in here, change this tool to a 375, and let's see if we can find it as a reamer. might be able to find a reamer that's just exactly what we want. We may just have to make one or modify one. So let's just take the example of using a 3/8 drill, and we'll do it on the low carbon. And we're going to go in and we're going to call it back up and do some selection to it. Let's see if we can take a second and just look through these just a little bit more. As you have your own tools, and as you make all of your own tools, you'll be able to have some customized stuff that'll fit what you want. I was hoping to find one. Might be easier to use a 3" or 3/8 flat end mill, because the nose up it will already be flat. We won't have to change any of the anything about it itself as far as shape wise, but we do need to change the speed of the beads on it. So what I can do is just, I've selected it. I can take this out. Actually, either way we can do it. We take this out. And we can edit this guy. Change the RPM down to about 700. Number of flutes, it probably has 6 flutes on it. And so we want to change the type of tool that it is, and then all the rest of that stuff should follow with it. Okay, so that's our reamer. We've selected it. Got that already taken care of. Now that one we're going to feed in and feed out on it. Okay. So what we have so far, we just named our spot drill, but we didn't name any of these other tools, so we need to go through and be able to identify these really well. Because we may not be running this part, maybe somebody else is running the part for us. So we want to go in and have good descriptions of it. So 25/64 drill. And then this is going to be a 5/8 flat end mill. This one is a 5/16 drill. .3/8 16 tap. Then this is a U drill. And this is a 3/8 creamer. Okay. So now I want to just shift this around so I can see it real well. Go back to the top, simulate the entire part. Now, when you're running the CAM system, you're just going to have to learn to accept certain things aren't going to be perfect. you can get almost everything the way that you want it, but you're going to have to determine how much time you're willing to spend to make everything happen just the way you want it to. So simulation doesn't always look exactly right. You want to try to stay away from editing the code as much as possible. If you can not edit the code, if you can run it in the CAM from the model, not making lots of changes or making changes in the model and then saving them as you go. When you're working in Inventor, everything's saving, so everything is kind of real time as you go, so you don't end up with older version of Inventor files. Everything should be up and current as you go. You can see this as a transparent, you can see the tool, you can kind of set and customize all of those things. And we'll be working on all of that as we go. We'll be working on probing, we'll be working on editing the code. What I wanted to do today, first class, was to get everything loaded up. And you can see it doesn't take long to make this, but at the same time, there's no way that this part will go out to our machine and be perfect exactly the way that we want it. It's going to be close, but we want to spend some time kind of refining some of those things. So next I want to go to the code. I want to go ahead and be able to post out a code so that we can have at least something that we can take to the machine. So the next time when we're in class, that'll be next Tuesday, when we can go ahead and bring them out to the machines. We can run them, we can figure out what's wrong with the code, we can come back to the computers, make any type of alterations that we need to. I want to try and stay away from making a lot of at-machine changes so that we can keep the code fresh and clean and clear and keep everything as we go, straight as we go. Okay, so if we've got something that we like and is workable and usable, we should have already been doing this as we go, or as we have been going. We want to save these files. So it's really important that we are saving our files, that we are naming our files as we go. I would recommend that you would just save to a USB all the time. And so just however you want to do yours, I'm saving mine on the desktop. This is my desktop that I'm using though. What I don't want you to do is I don't want you to go to, I don't want you to draw something on one computer and then move to another computer. And then I also want you to realize that as we work, especially when we get to turning, we're going to load in some add-ons that'll come up in here, Cool Orange and a couple of other ones that we go. Some of those are already in our image when we load it in here. Some of them won't be. So if we like what we have now, then we can go ahead and go to post-process. And post-process is when we actually create the code or bring the code into something that looks right to us. So what we're going to do is we're going to come in here and we're going to find our machines that we're going to be using. So I generally, just to get started on something, I'm going to go ahead and just say we're going to use the Haas UMC 750. That's actually not exactly what it is that we're using, but it's going to be pretty close for what it is that we're starting with. We're going to get into how to edit the post library and create our own post library pretty soon, but we can configure that however we want. It's going to ask a lot of questions in configuration where we can go in and change some of the stuff, but we do not have to or need to or even want to do that stuff today. So it's going to give us a chance later on to answer some of these questions. Those will be great to try and get this program the way that we want it. So that our whole plan is to output code faster. Sometimes it's going to be faster to create a CAM program like this. Sometimes it's going to be easier to offline program, and then sometimes it's going to be easier to just program something right at the machine. So let's just post this out for a first try, and it's going to go ahead and save it in the Inventor HSM NC file folder. It's going to come up, and when it does, it's going to bring it up in NC Editor, which if you're used to using NC Editor, it's going to be awesome for you. If you're used to using Notepad, it's going to be just a little bit different. So what it's doing is it's highlighting different colors. Different colors mean different things. So anything in parentheses is blue. Anything that is just General coding is in black. Rapid movements are in red. And then as you go, you'll also see some green and some other things. So you can also change those if you want to. There's a lot of customizing that you can do on there. So we've got G1s in green, and so we've got a pretty decent code here. The only things that are really going to give us any kind of a problem, for the most part, this code will run just the way it is. Now, if you don't like, or you do like having the line numbers in here, N30 and 35, you can customize that too. You can remove those line numbers. I don't typically use line numbers. So we know that this is 6500 is pretty fast for our face mill. And even though that's a real quick change here, it's also a real quick change out on the machine. It doesn't really do us any good if we're going to go and mess with the program here and then save it, and then go out to the machine, mess with the program there, and then save it. And then when we go to run it again and we pull it off of our computer, laptop, network, whatever it is, it won't be the same, and then we're going to end up spending about 2 hours in program edits again. So instead of going through and editing this, it's smarter to go back now and just change it. So we can close this and go back to this face-off and go back into this tool. I can edit this tool, and for speeds and feeds, maybe I want to go something like 2000. I got 5 inserts, that's right. If I want to stay even lower than that, I can customize this how I want to go ship load. So maybe even 1800 or 2200. Say go 20. Let's go 2000 just on this one, just to keep it clear. If I wanted to go in here and I can just go 5000 chip load. If I want to do that, 2000 RPM, 5000 chip load, it's going to adjust my speeds and feeds to make that stuff work. Close that. Hit OK. I've got to regenerate if I do that. I usually just go ahead and regenerate all of them. It takes just a second to do it. Go back to post-process. It's still my same program number. It's still all my same information. Just going to ask, do I want to override it? Yes. Now I'm at 2000 RPM. One thing that will change as we go is this G53, X of -29, Y of -8. That's going to shift our table over. That's normally not one of my favorite things to do. This V and C rotation, it's a 5-axis machine is what this 750 is. The ones that we're going to be working on are just going to be 3-axis. That is not going to affect anything. If it just annoys you, then you can go back into the post processor and you can make adjustments for that. The other thing that's going to throw some people off is, depending on the type of tool changer that the machine is, it's calling up tool 1. So we've got M6 tool 1 there. You can switch those around too if you want to. Here it has T2. All that's telling us is put tool 2 in standby. So if we have a chain or a tool changer that allows us to have standby tools, we can go ahead and do that. But you can see tool 1, H1, if we're using cutter compensation on any of our tools, it would also then be D1. But we're not in this one. It's going to use a circular interpolation to try and keep the in-mill, face mill on there as often as possible, or as much as possible. Which, again, if you're used to hand programming, that's going to be just a little bit harder to grab. And there are certain things on this that I just don't love. When you get done here, G53, G0, Z0, spindle's going to go up. That's awesome. But here you have our coolant off, which is really at the next set of commands. So coolant off, optional stop, then change tools, then turn our spindle on, G54, B and C indexing to 0, turn the coolant on, plane change, all of that stuff is coming through. Again, H2, so those things are all right. They're just going to be annoying. You're also going to see some different feed rates for different things. That's in effort to try and keep it moving as fast as it can to keep as much contact in there as you can. They're not bad things, but they're just not always going to be things that everybody's used to, especially if you've done a lot of hand programming before. If you come out of the operator class, you don't know what that means anyway, so it's not going to really bother you. But if you've already been programming, if you've already took 109 and you're backtracking back into CAM, then some of those things are going to be a little bit more difficult for you. So this will be our code. It will be extremely long. In the grand scheme of life, it really doesn't make any difference. So as of now, I would be confident in just running this code. So what I want you to do is go ahead and save this code and just create a file that's called 123 block first try, and we'll just do a save as, and you can put it wherever you want. I'm just going to put it in my NC file folder. So I got no changes in it, so it should have remained the same. And then I want you to go ahead and submit that to me. So submit it in the Blackboard Dropbox, and then next time that we meet, we'll go ahead and work through any type of problems that we might have had. So don't not submit it and don't do the work and just say that we're going to edit it then, because we're not. I want you to submit the work, submit a file to me. We will play with it again next time when we meet, and then we're going to come out to the machines and we're actually just going to run the parts. So we'll make quick adaptations as we need to, and then we will run the parts and then see how it works for us, how quickly it works for us, if we like it, some pros and cons. Okay, so do that for me, and then that'll be the end of week 1.